Okay, so the picture that I chose for the Desmos art project was a Christmas tree. I just thought it was very suitable for the time of year, and I like that I could have put a lot of different shapes inside the tree, like ellipses, circles, ordered pairs, just to put little points on the tree. I did absolute function values down here to just add a little bit of detail down here. I could have chosen a lot of different things for the top of the tree. I could have chosen a smiley face, a star, any sort of basic shape using different functions. So I decided to go with a smiley face just because it includes a circle as well as just ordered pairs here and then a parabola here to form the smile of the smiley face. And then to form the sides of the tree, I took a lot of time to figure out the different functions to use, but I mainly use exponential functions and logarithmic functions just because they kind of go in these directions, but I had to use a lot of restrictions so that the logarithmic functions and the exponential functions didn't go past the line or past the tree. So this is the general shape of my tree. Right now I just have the bottom of the stem here. Oops. And I just used a basic linear or constant function y equals -2 with a restriction. And what I'm going to do is form a hyperbolic function to form the sides of the stem. And then I'm going to show you how I add another ellipse inside the tree as well as a trigonometric function to kind of look like garland to the tree. So far I have a sine function with a slider so I can kind of move how the garland would look on the tree. And I'm going to do another one up here. So first I'm going to create another ornament using an ellipse. So these ellipses have pretty small radii just because of the restrictions on my picture. I mean, the furthest restriction goes from -5 to +5. So my ellipses have a pretty small radius. So I'm just going to form another ellipse right here with a center of -2, +4. So that'll put it right up here. So in order to do that, I'm going to type in x plus 2. I'm using the little caret for the squared, plus y minus 4 squared using the little caret as well. And I'm going to make a pretty small radius, 0.1. So this forms a circle, not an ellipse. So a circle ornament. So these are ellipses here, as you can see by the function here. And I made a slider for the radius here to make the ornament bigger or smaller here. And then what I just formed is a circle with no restriction. So I can't change the radius of it. I can't change the center of it. It's just kind of put where it's at. Oops. Next thing I'm going to form is the hyperbola down here to form the other sides of the stem. So I'm going to form a hyperbola with a center of 0, -1, and again, a pretty small radius. So my hyperbola is going to look like this, x squared, and I just push the little right arrow to get out of the exponent over 4 minus, since the hyperbola, x plus 1 squared over 4, and again my radius is going to be pretty small. So this is what my hyperbola looks like. I obviously need to form some restrictions so that it doesn't go past the tree and through the tree. So in order to form my restrictions, I'm going to make my restrictions at -1.732 to +1.732, just because I calculated this beforehand. So this is what my hyperbola would look like with some restrictions, so it doesn't go past the tree. So this is my stem of the tree. And then the last thing I need to form is the cosine function to form another garland. So I'm going to type in cosine, and I'm going to create a slider for f plus 4. And again, I'm going to form a restriction of -3 to +3. And I'm going to add a slider here so that it actually shows up on my graph. And this way my cosine function can be really, really, really skinny or really, really wide. So the most normal would probably look a little bit wider on the tree. something like that. So that is with my conic, my hyperbola, my restrictions for both my cosine function and my hyperbolic function, as well as my circle with no restriction at all. So this is what my finished product looks like.